So yeah, what I want to do today is do that 2D bouncing stuff like the Office episode. So I'm very excited. We're going to have that bouncing square bouncing around on the screen, and hopefully it might hit a corner, like was the objective of that scene, right? But the goal is to give it some random direction and have it just start bouncing around until it hits a wall, and then bounce off in the way that makes the most sense, right? Don't go like straight back out, do a 180. You gotta move in the way that you're supposed to move, and maybe eventually you'll hit a corner. Something like that. So that is the goal, and we talked about it last programming lecture, how we're gonna do it, right? We had, we're gonna hook into a lot of stuff that we had with the bounce up and down code. We're gonna draw the boundaries of our screen, and so that's gonna be a 400 by 400 square, centered at 0, 0, and so the coordinates, if you want to think about them, involve 200s because it's like perfectly centered around 0, 0. And so like this coordinate would be what, negative 200, positive 200, and then this one would be positive 200, negative 200 on the y. So that's where we're going to bounce the ball around. That's going to be its playing field. And then the next thing that we want to do is make a square in a random location somewhere within those boundaries. So we're going to have to turn the turtle into a square instead of a circle like we did before, and then give him some random coordinates between like negative 200 and positive 200 on the x, and then negative 200 and positive 200 on the y. Taking care, though, because the center of the turtle is always, or his coordinate is always relative to his center, so it can't be like exactly equal to 200 or anything, negative 200, because then it'll be like straddling the wall there. So we have to account for that, but still random numbers, like pick random x and y within a certain range, and plop your turtle there. And then we have to give it a random location, or sorry, a random direction after the location, random direction to move in. So you could bounce off in any of these directions, right? We got to pick one, and have it be different every time, have it be random. So let's say that we randomly choose this direction. We know how to represent that now inside of a computer. That's exciting, right? It's going to be this direction is associated with an x offset, move a little bit in that direction horizontally, and then a y offset, move a little bit in the vertical direction, and that will give you sideways movement if you do both at once, right? And then just like that forever, now we're ready to loop. We have a direction, we have a starting place. We want to just like nudge every frame, nudge the turtle, the box, in that direction as long as there's nothing in our way. So bam, 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 bam. Usually you could keep going in your current direction, but you might hit a wall. All right, so this is very similar to our bouncing ball. It's just we have another axis to worry about, and that's going to mess with the way that we choose our new direction because we have 2 dimensions. So like we're going to notice how we hit a wall. We still have we're going to use the same if statement for like the top and bottom walls. We're going to change our direction to be this. Hit a wall, bounce off, and just like keep doing that all day long, forever. Nudge the turtle in its current direction until you can't anymore, until he hits a wall. We'll notice that with an if statement, and then we'll have to change our direction. If the turtle tried to go outside, we'll have to rein him back in because you might move a little too much every frame if you're moving quickly. Rein him back in and then change the direction so that we bounce off in the correct way, right? So hopefully that's coming back to us. Does that make sense so far? Any questions about that? So I'm going to steal a lot of the code that we had last time, and I might as well, let's see, what do I want to do? Yeah, let me do one more slide, then I'll go to code. All right, so we kind of zoomed in on those ideas as well last time, so let's remember what we were talking about. So we'll make the turtle the square, and it'll have the little coordinates that we can use. So the turtle has a coordinate relative to his center, so like that's his xy right now, okay? And then again, the direction will be, just like we were doing for up and down motion, it was like a y offset. We're going to have an associated x offset and y offset. We're going to have two at once to give us sideways movement, all right? So that'll be the beauty of all of that. We'll have 2. So if we want to move in this direction, for example, we're going to have an x offset, that's that much, and a y offset, that's that much. I'll call that like x off, and y offset, y off. Something like that, okay? And so what we want to have happen every frame we want to nudge the turtle in his current direction. And so like you were at XY, Mr. Turtle, after one frame your center should be at your old x plus the x offset, nudge it in the x direction, and then also nudge it in the y direction by the y offset. And so these could have been negative or positive, depends on like if you're moving up and down, side, left and right. Okay, so that's what we're going to do every frame, and yeah, every single direction that we could possibly want to move in has an x and y offset. You want to go this way? That's positive x, positive y. You want to go this way? That's what? Negative x, positive y. You want to go this way? That's negative x, negative y. This way is positive x, negative y, and then everything in between. It's just like amounts, differences. Okay, so that's what's going to happen there, and I believe I'm ready to go to code now. All right, so let's steal a lot of stuff that we did before, and we'll go from there. So this is lecture 27. We'll have to make a folder for that. We'll open up idle and remember the number 27. Let's see if I can steal our code from before, like the original bounds program, not the one with gravity, the original one. So maybe, let me check my notes. Let's do this one, bounce.py. It's from lecture 24. So I'll copy all this into a new file, and I'll save it in a new folder for lecture 27. And it will be 2D bounce.py. That's what I'll call it. But right now it's just doing the 1D bounce. All right, so this is all the stuff from before. This is the constant speed one program. Is it working? There it goes. So this is what we had from then. Okay, so it's just the constant speed ball bouncing up and down, and the ball's a circle. Okay, so we're going to hook into this and go from there. So let's see. Lower level game plan time. So we had the turtle being a circle in this example. We're gonna, maybe first step should be make the turtle a square. Okay, so let's fix that. Let's do that first, maybe. So we still need the bounding square, still at 400 by 400. It's perfect, centered at 0, 0. And now instead of making the turtle the ball, we'll make the turtle the square. And everything else should be the same. Give them a different color if you want, purple, doesn't matter. But we're going to say turtle shape square. All right, and that'll give him a square shape, and he'll still be stretched in that amount, and his width will still be 40 units, and that should make him look like a different colored square now. And so it's moving up and down, and we're going to have to fix that. But that's getting better, getting closer. So that's the first bit. Next is going to need to be how we deal with directions. All right, so we have to pick a random direction, as well as, I guess we also need to pick a random starting location too, huh? So maybe we should do that first. Let's say we do have to worry about his size, but let's see, how do I want to fill this in? This is where the square should be now, I guess. These variables, turtle x, turtle y. And this was like his initial location, right? His initial starting point was this x coordinate and this y coordinate. It was like, this was hard-coded to be the top of the screen, and then this was a random x coordinate. All right, so it was always at the top of the screen somewhere to the left or to the right. So if we hook into this, we can make a random location anywhere inside of our bounds. We can say, make the turtle x be like random between like negative 150 and positive 150. That won't go outside of the bounds, is with this 40. So that's golden. That's perfect right there. And we can do the same for the y. And this will put them at a random spot within the bounds of the square. It's not at the tippy top anymore. Okay. So if I show you that, I hope that makes sense. This is the starting location, right? That's the very first place the turtle is going to go to. And the turtle is now the square. So he's starting right there now. If I rerun it, still moving up and down. But now he's down there. So it's just a random spot somewhere within this window now. So that's getting better. And then the next piece of the puzzle needs to be our direction, right? Give the square, the turtle is the square, give him a random direction to start off in, and that just is going to be, well, pick a random x offset and a random y offset. Does that make sense? That's what we're going to need to do now. So let's see. I'm going to need a random number that could be like have decimals. I need a random not integer. I need a random float. All right. So there's something in the library for that. So Python random. We're gonna need not just random.randint, because that's just like integers, whole numbers. I would like a random number within with decimal places within a range. I want a random float essentially. And what function is that? I think it was, okay, yeah, it was uniform. Random.uniform gives you back a float. There it is. Random float between a range again. So that's perfect. I'll have decimal places, and so we'll have everywhere in between. And so that's what I'm going to use here to pick a random x offset and y offset. Because I want everywhere in between, right? Maybe I want this direction, which is going to be like baby x offset, large y offset. Or I want even worse, even more straight up, tiny decimal place x offset, large y offset. See that? So I want tiny numbers potentially. So I'm going to use random.uniform to pick a random direction. And so we were doing the direction with the offset variable here. That was just the y direction. So we need two variables. We need one for the x offset and one for the y offset, like x off, y off, whatever we need. We just need two variables now. We had one. This one was the y offset essentially. And we also need one for the x offset. X offset, y offset. And so I'm going to use these two variables. Taken together will form our direction, whatever we pick first. And I would like a random direction. So random, go a little bit in the x direction, like random.uniform. Some number with decimals in between, like -1 and 1. Okay? So some potentially tiny number. And then same for the y offset. Let's just pick a random number between -1 and 1 that has decimals anywhere in between on the number line. Maybe it's -0.6 and then +0.7. That would produce this direction, something like that. So that's what we're going to use to have our direction. And let's see. I think that's a good start. Does that kind of make sense? We're going to use those two variables. And I think we're ready, right? What do we do each frame? We want to move the turtle's x coordinate and y coordinate by our direction. So change the x by x offset. So we were here. We want to move in our direction to there. So add on our offsets to our coordinates. And so that was happening in draw frame, right? Down here it was while true, repeatedly draw a new frame. And what draw frame did is it was messing with the turtle's place, bouncing off walls as well, and then redrawing the turtle. Okay, so I'm going to need to change some things around. I am messing with turtle y and turtle x now. So I need to say that I want to do that. I want to mess with these things. And then I'm also going to eventually mess with each of those offset variables. And it's not just called turtle offset anymore. It's called turtle x offset and turtle y offset. These ones. So I'll mark them as global as well because I might want to change them. And so here's the key right here. What we'd like to do is, let's see, change the turtle's x and y coordinate by the offset. So y offset. Y coordinate needs to be changed by the y offset, and then the x coordinate needs to be changed by the x offset. X coordinate by the x offset. So if he was here, your next place after this frame is this new coordinate. Add on the offsets to your existing position, and that'll nudge you in some direction, right? So I think that's what I wanted to do there. And then this code is wrong. We don't have a variable called offset anymore. It's going to throw an error, but this is close enough. This is good enough for now. All right, so let's watch this work. So again, we're drawing the bounding square. We're making the turtle the square and giving him a random starting place that's anywhere within our bounds, and giving him a random direction. And each frame, if we don't hit a wall at least, we're going to nudge him in that direction by, this is the x offset and the y offset. Okay, this code is not quite correct anymore, but we'll look at it. Let's see what this does. Whee! Let's see, did I say something wrong? looks like line 67. I say something wrong here. Go to turtle x, turtle y. What is it saying? Oh, thank you. Yeah, I'm going to need to change that for sure. Go to turtle x, turtle y. So it's unhappy with this line for some reason. Down here at the bottom. Do those variables not exist? Let's see what it's saying here. Draw frame, turtle.terminator. I guess it may have to do with the fact that my bouncing code is not quite correct right now. Let's try it again. I did have to change that x, so thank you. Okay, it's happy now. Awesome. Look at it. And then, of course, it's going to have an error on the bouncing, but it had a random sideways direction. Isn't that cool? Let's see what other random one it picks this time. Up until it likes up and to the left. So that was a negative x offset and a positive y offset. We can print out our initial directions as well here. Let's print it out. Let's say print, maybe like right here. Print turtle x offset, turtle y offset. Let's do that and then try it. So let's see what our random direction was. It's apparently close to -1. So like on the x, go left a lot and then go y, go up not as much. Positive y offset. So it was moving left and up. What about this one? This one is going to be, okay, so positive x will go right and then down -y. See that? Any questions about why those numbers, they're random and they're producing movement in a sideways way, sideways motion with just two variables. So we added one more. We had one for the y before, which is called something different, and then we added one for the x. That's so nice. We got a lot just from that. Just from that. All right. Let's see. There is a slight issue with our directions right now that I do want to get into and fix before we fix the walls. Well, that one worked nice because we don't have any sideways direction, sideways wall checks yet. That's funny. So you see how these numbers could be very small. That could pose a problem if both numbers are small. We're going to get any of that? No. Just thanks to randomness, it's not showing me the problem that I wanted you to see. So here's kind of an issue. Let's say that we choose randomly. Let's say that the turtle chooses this direction to move in. Like it wants to go up and to the right. It could have chosen that direction randomly, that same direction in a bunch of different ways, couldn't it have? It's like, it all depends on the size of the triangle. Like you could have chosen like a 1-1 triangle to do that. This could have been a what? Is there an ant on this? That's funny. This could have been like 0.25, 0.25. Do you see how that's the same direction? But this one will be slower because we're moving at just 0.25 on the x, 0.25 on the y each time. That's going to produce slower movement than this one. And then like one that's in between is like 0.5, 0.5. You see how that's all the same direction, but just thanks to the random numbers and like the fact that they have this range, like this one would move slower in that same direction than if we chose the x offset to be 1 and the y offset to be 1. Does that kind of make sense? I don't like that. So I would like it to be the case that always the length is exactly 1. I think that would make the most sense. Like no matter what random direction you pick, your speed is always the same. Okay? I'd like to do that. And so essentially, I want to choose a direction like this. Imagine that my direction, my arrow, is like the radius of is like the radius of a radius 1 circle. It's like pick any direction, it's always 1. Choose an arrow there. And so there's a way to choose that randomly with like sines and cosines. You probably you know how to do that, to pick a random point on a circle of a certain radius. You can probably figure that out. But an easier way is like we have been given some triangle. We've got our x offset and y offset. We've got those numbers already. They're in our variables. Kind of what we'd like to do is solve for the length of the hypotenuse and then divide it and make sure it's 1 by the end. So like we've got A, B, and C. And we know that how to find the length of the C, right? Because C squared is equal to A squared plus B squared, where A and B are like X offset and Y offset. We'd like C to be 1, so like, how do you solve for C? Like, take the square root. We'd like C to be 1, and if you've taken a fancy advanced calculus class, you will know that a way to get C to be 1 is to divide A and B by this number. If you do that, then that will force the hypotenuse of that triangle after that has been done to be exactly 1. Okay, so that's called normalizing. We're going to normalize our offset triangle, our direction triangle, so that like this is square root of 2 or whatever. We're going to divide both of these by square root of 2, and that will force our arrow in that direction to have length exactly 1 unit. Okay, that's what we'd like to do. We're going to normalize this, normalize the vector, if you've heard those words. So the distance traveled every frame is exactly 1 unit, because that is going to give us that movement. Okay, so to do that, we want to divide both the x offset and the y offset by this number. All right, so let's calculate that. Let's see here, where do I want to do that? I guess here I am choosing our direction. I don't need to print it out anymore. What we would like to do now is normalize our offsets. Let's normalize our direction so that it has a length 1 hypotenuse. All right, so the way that we do that is we have to calculate the length of the hypotenuse, which is like this is a triangle, this is the width, this is the height of the triangle. And so let's get that length with the math library, because we're going to need to take a square root, right? Import math. I want to do this calculation, right? The square root of x offset squared plus y offset squared. So that's what I like. Let me show that to you. There we go. So I need the math library for the square root function. And so let's get that direction hypotenuse length. It's going to be, well, you do a squared plus b squared, where a and b are these guys, x offset and y offset. So turtle x offset squared plus turtle y offset squared. And then we're going to take the square root of that. So that's going to be math.sqrt, right? The square root of that, that's the length of my current random direction arrow. And if I just divide x offset and y offset by this number magically, that will make the resulting direction arrow 1, length 1. So take the turtle x offset and keep it, like divide it by whatever it is. Take it and divide it by this length. Okay. So if I do that to both of them, the x offset and the y offset, then that will guarantee that the arrow, that triangle, that is the direction now, has length exactly 1. Okay? So now the length of the hypotenuse for my random direction is guaranteed to be 1. No matter what. Alright? And this should even be true in the special cases where A or B is 0, I believe. That should be fine. So, after I do that, you will notice that no matter the random direction, the speed is the same, right? Speed is the same in that direction. It's like perfectly equivalent. They're all the same. So that random direction, speed was something. Keep that idea of that speed in your mind, replay it. Same exact speed right there, okay? So that's different to what we were doing before. If I comment these out, maybe what I should show you is like if I didn't do that, kind of watch. Remember how fast it was before, how normalized and nice it was. If I didn't do it, the direction is a little bit slower than last time, I think. Just like you're at the mercy of those numbers at that point if you don't do that. So that one, see, that's moving super duper slow. We don't want that. We want to normalize it. Perfect. That's exactly what I wanted to show you. So let's bring that back in. Do that division to force, no matter what direction we choose, force it to be length 1. So that no matter what we choose, it's always going to move in the same amount. Okay? That's called normalization, and it is very useful for us. Does that make sense so far? So that is going to be the bulk of the work. Now we just have to worry about the walls, right? So let's see. Do I want to separate that right now? I'll do it later. Now we have to worry about the walls. Okay, so the up and down walls, we do have the right if statements to check, did we hit the wall, right? So was the y a little too small or a little too big? Then we hit the top and bottom walls. But what we're doing in here is wrong right now, so we're going to have to fix that. And then we need also some cases for the left and right walls. Let me try and draw what's going on and get all the magic numbers. It has to do with the width again. So it's not exactly 200, it's 200 minus half of the width. And so the magic number for us is 180 or negative 180. So let's see. We had our bounds. This was what? Negative 200, positive 200. This was 200, negative 200. And then like this was 0, 0 right in the middle there. And now the question is, when do we hit a wall? So the side walls, for example. We hit the side wall when, let's say, potentially we're right here. We just grazed that side wall when what is true about the turtle's coordinate? Well, it's not having to do with the x-coordinate being negative 200. It's really having to do with the center point of the turtle, this one right here. All right, so that's like, if it gets right there, we have a problem, okay? So let's see, how do I want to draw this? Because this is what? This is the y equals 200 line, y equals 200 line. This is the x equals negative 200 line. This is, and then you can kind of understand the rest, I think. So, okay, so it's not when the x is negative 200 do we think it hit the wall, because that's when it would have been right here. Instead, we want to take into account, because the center of the turtle is here, and that's where his coordinate's going to be relative to. We have to take into account the size of the turtle. So he's 40 by 40, okay? And so really, what we want to do is notice when the turtle is right exactly there. Does that kind of make sense? So it has to do with x-coordinates when you've hit a side wall. And so it's not negative 200 on the x for the left wall, it's negative 180. If the turtle's x-coordinate is negative 180, or it tried to go even farther because we're moving fast for some reason, then we've definitely hit the wall or tried to exceed it, okay? So that's what we need. All right, so the turtle's hit the left wall when the x-coordinate is less than or equal to negative 180. It's just grazed it if it's exactly equal to negative 180, but due to our speed and the way that we calculate frames, it might move a little too much and try to exceed the bounds of the wall. We're going to make sure that we rein it back in as well. So it could even try to go less, okay? So that's the left wall. And then same for the right wall, right? So the right wall, like we notice that we hit the right wall when this is true. It's again the x-coordinate, right? It's when the x is not exactly 200, but the x is equal to 180 or above. We try to move a little too far to the right. Does that make sense? So that's exactly what we're going to have to compare against for the right wall, and then the top and bottom walls we've already kind of done, right? It's the y-coordinate that got us in trouble for the top and bottom walls, right? This is going to be check the y and make sure it doesn't exceed 180, right? It's either exactly equal to 180 or a little bit less. And then for the bottom wall, it's negative 180 for the same reason, right? So this is like, you got your too low when you're right here or below. Y equals negative 180. Okay, so those are all the things that we need to check. And then we have to worry about what happens. Okay, so let's, how do I want to do this? I guess that would work. So this is noticing we hit the top wall, or sorry, the bottom wall. This is the top wall. And we want to do something similar for the left and right walls. So we'll have to add some code for that. Let's see, how do we want to do this? Okay, so we can do the x's before the y's. Still, the body of these if statements, they're not correct yet. We're going to have to fix those for sure. But let's get the scaffolding ready. So maybe I'll just put question marks for now because we're not ready to put stuff in here yet. But for the left wall, that's going to be turtle x, right, was less than or equal to negative 180, which is exactly this. You can get it with the width variable as well. So that's that one. We hit the left wall. Maybe I do kind of want these comments for now. We're going to have to change the body, of course, but we either hit the left wall or we're trying to go past it. I don't know how we want to say that. Past it, and then we want to move the turtle back inside and change the turtle offset so we move like rightwards now. Something like that. But the code that does that is wrong, so let me just like delete those pieces of code maybe. That's probably the best, right? And then same for this one. We've hit the right wall if our x is greater than or equal to 180, which you can get by subtracting half the width from 200. All right. So that's if we get here, that means we either hit the right wall or we're trying to go past it. Move the turtle back inside. We'll change the turtle, one of these turtle offsets, so they move to the left now. Change the question mark. We'll have to deal with that in just a second, okay? But that's how we notice. Does that make sense? So these will be true if we hit the left wall or the right wall. We just have to do the right thing to fix it and bounce off, okay? So that will be that code. And now let's figure out how to change our direction. It's going to have to deal with the negations, okay? We're going to have to also split this up into a function just to make it easier. We're going to make a bounce if hit wall function just to make our lives easier. But let's remember what has to happen when we're bouncing. It's very hard to draw straight lines. Here is our bounding window, let's say. And let's pretend that we've hit the left wall. So our coordinates right here, we just hit the left wall, and we got here because our direction was that way. We were moving that way with this x offset and this y offset. That was our x offset, that was our y offset. What do I need to do? If I'm coming in this way, I want to bounce off that way, right? So on my new direction should look like this. That's my best scale, I think. And you notice that that's the same triangle, just mirrored on the x. All right, so you're still going up with the same y offset, but your new x offset for your new bounced off direction, do you see how it's going to be the negation of what the old x offset was? Like you were going left, now you need to go right, so that's going to be a sign change. All right, so that's the secret. You want to negate your x offset if you're hitting a sidewall, and same for the top and bottom walls, it's the y offset. Negate the y offset if you're hitting the top or the bottom walls, because like say we hit the bottom wall, our direction that got us into trouble was this one. We're moving this way. And we want to bounce off, right? We hit that way. We want to bounce off that way. So my new direction should be this one. And we can get that by like, all right, this was go downwards and right. Now I want to, by the same unit amounts, I now want to go upwards and right. See that? It's going to be the negation on the y offset. Okay? So that's the secret there. And it's going to be symmetric for either side. It's always the same. So like if we hit the right wall, it's still negate the x offset. It's like if we're hitting the right wall because we were coming up that way, we want to bounce off that way. So it's still going to be like you were going right and up. Now you want to go left and up. Okay, so it's still the x offset that needs to be negated for the other side wall. So similarly for the top wall, it's negate the y. It's like what was positive becomes negative and what was negative becomes positive. It will work for either side. Okay, so yeah, let's have this code. Let's split it up, right? Let's have a bounce if hit wall function. It'll make our lives a bit easier, I think. So I'll call it this, and then that will also make our draw frame much simpler. Def. I don't know how to do it yet, but let's like hand off the problem to this code, all right? And I'll steal all this wall checking stuff. Let's actually keep the stuff that we had before first, because like we can look at that. It can be on top. The order does not matter. One of these guys like that. There we go. And so I've just handed off the problem of checking if we hit a wall and bouncing to this function, which is very nice for me because now in draw frame, like what do we need to do? It's just like, all right, move the turtle if you can, and then bounce if you hit a wall. If we hit a wall, bounce off. And that's just like, well, that's a call to my function, right? Bounce if hit wall. Do you see how simple now draw frame is? Like, all right, repeatedly draw a new frame. What do you do every frame? Nudge the turtle, bounce if we hit a wall. We now have a new x and y coordinate, go there. Isn't that nice and simple? It's so much easier to reason about than having it all in one place. And now our problem lies with dealing with this function. Now we have to actually go and implement it. Like, what does it mean to bounce if we hit the wall? But this is nice and clean code now. So like we've handed off the problem to ourselves, just somewhere else, like an IOU. But that makes this code much cleaner than putting it all there. So let's do exactly what we set out to do. So okay, if we hit the bottom or the top walls, it's going to be the y offset that gets negated. All right, negate the y offset of the direction if we're hitting the top or the bottom wall. So let's change the turtle y offset so that we move upwards now. Y offset, y offset. Change the turtle y offset, y offset, y offset. So that was for the top wall, that was for the bottom wall. Change the y offset. And then if it was a side wall, let's see here. I guess I don't need this comment anymore because the function is called that now. It's going to be the x offset. All right, so let me steal some of this code just to make it easier. Boop. So, all right, move the turtle back inside. If you try to go past the wall, it's going to be like your x was exceeding this. Bring it back in. That's still fine. Move the turtle back inside to be exactly equal to that number, negative 200 plus turtle width over 2. So that's negative 180 if you try to exceed that. And then we want to change the turtle x offset. It's going to be the x offset that gets negated whenever we hit a side wall. So that's this one. X offset changes to be the opposite sign. So it's x offset changes there. All right. So that's for the left wall, and then for the right wall, it's again your x. The thing that got us into this trouble was trying to go potentially outside of the bounds. So make sure to rein the turtle back in for its x coordinate to be exactly equal. Like don't go farther than this. Like rein him back in. Make him just graze the wall. So equal to exactly 180. And then we want to change our turtle x offset, negate it. So we move to the left now. All right. So that's going to be my bouncing code. And I think that should do it. Does that make sense? All those words? That should do it. I am changing a lot of these variables inside this function. Those are global variables. I do have to mark that. I have to mark that right here. I'll just take all these. Like I'm changing potentially all of those, right? So I'll mark them as global so that I can mess with them. That's the last piece of the puzzle. So now it's like draw frame makes a whole lot of sense. Like nudge the turtle. If you hit a wall, like undo your work and like bounce off as well, change your direction. And then go to that new XY, because the whole job was like to change XY in the right way to get us in a certain spot, right? And then if we hit a wall, we're going to bounce off, we're going to notice it, and then rein the turtle back in if we try to exceed the bounds, and change our offsets, the correct offsets, to bounce off in the right way. Okay, so I think that was what I wanted to do. The pit wall is the star of the show now. It's the new stuff. All right, moment of truth. Oh yeah, that's very satisfying. And it might hit the corner right now. It's perfect. Not quite. And then, all right, we're hitting that was the right wall code. So that was this code right here. Tried to exceed it. That was the bottom wall code. That was right here. So we're going to mess with the turtle y and then like also change the offset, right? That was the top wall. So we're going to make the y offset negative now. So we're going to the bottom. That was the bottom wall. So we're going to make the y offset positive. So we're going upwards now. And then we're going to get the left wall. Here's the left wall. X was too small, so we're going to make the x offset positive. So we move to the right now. So yeah, isn't that fun? I like that. And then it's going to be a different direction, a starting direction every time. So it might be more sideways, more horizontal. It depends on randomness. I'm trying to get a perfectly diagonal one. We're at the mercy of randomness right now, though. That's decent. So yeah, just like, all right, every frame, we're changing our x by this, y by that if we can. Usually that's all we need to do. But sometimes if we hit a wall, we always want to check, did we hit a wall right now? Did we hit a wall right now? Because that might mean that, okay, we're going to have to mess with either X or Y and then either X offset or Y offset. Potentially both. Potentially both. All right? So yeah, all this code is working nicely together and giving us what we need. We're checking each wall separately with 4 separate if statements, which is maybe a little lazy, but it's all working out. Any questions about this code before I talk about one last maybe potential problem? So, we do have to be very careful. You might think that, like, okay, I can use elifs. We know about that. It's like do one body only. It's like, all right, if this wasn't true elif, try this one. And that's fine, right? Because you're never going to hit both the top wall and the bottom wall. It's one or the other always. But if you make all of these elifs, you do run into a problem. Because, just like in the Office episode, you might be hitting the corner. And what does it mean to hit the corner? That means you hit the right wall and the top wall at the same time. You see that? And you have to account for both of those in your new direction change. So you want to make sure, you have to be very, very careful about that. You need, like if you hit the top wall and the right wall at the same time, you want this code to fire as well as this code, not just one or the other. See that? You have to be very careful about that, otherwise you won't bounce in the right way. So you cannot make these all elifs. You could make the top bottom if elif, and then the left right if elif, because you can never hit the left and the right wall at the same time. That's physically impossible. That's fine. So these can be like 2 connected chunks. Like that's a connected chunk, that's a connected chunk, and so you are saving time by not having to try them all in that case. But they cannot be all in one line and with a bunch of elifs. Okay, for that reason. So I'm just going to be super lazy and just try them all because like the computer's fast enough to deal with that. But you could have been a little bit faster by making it like connecting these and connecting these. Okay, that's what I wanted to say about that, I think. So we needed at least 2 separate if elifs if you're going to go that route. Not just one big long if elif, 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 right? Yeah, so I think that's everything. So we got code that it works, and I'll give you all of this so that you can study it. It'll be very fun. And yeah, let's see. Ooh, this might hit the corner right there. Oh man. If you wanted this to move faster, it has to do with the size of, like we were talking about, it has to do with the size of your direction arrow. And that's the X offset and the Y offset. Those are numbers associated with those things. So if you wanted the turtle to move faster, you would change the length of that hypotenuse again. Like we know that it's 1 right now. We can like multiply it by something, like by 2 or something, and that will make it, that will multiply it by what? The square root of 4? I think it is 2. Sure. You can give it a random speed with it by doing that. Yeah. That would be fun. Yeah, so I encourage you to try that. Let's like multiply it by 5 so that like the direction vector is, or the direction arrow is potentially length 5 or more than that because of weird Pythagorean theorem things that I can't think of in my head at once, but wow, it's moving 5 units every frame now, or more, depending on if I'm doing my math right or not. But it should just be 5? Okay, good, thank you. I don't want to say something that's not true. I wasn't sure. So that's 5, maybe that's insanely fast, but look at it go. And so you're seeing everything run a bit faster. It's just moving every frame, it's moving it more. It's moving it more, moving it 5 units at a time. That has to do with the direction, the size of that arrow, right? And so we took care to make it 1. Now it's like length 5. Cool. So that's true. Just imprecision. But thank you. Yeah, I wasn't sure if there was going to be like a square root secretly in there. Thank you. It should, yeah. For the length, you're going to take the square root of that, and so that should cancel it out, I guess. Cool. So now it's back to 1, and so it's nice and easier on the eyes, maybe. But yeah, you can play around with that. You can change the color of the ball by changing the fill color of the turtle. Yeah. So I'll give you all this code that you can play with. Try the random thing. I think that would be fun. And I think that's all that I want to say about this for now. Any last questions? All right, because I have one more thing to talk about for the day, as far as code is concerned. Let's see here. I would like to show you how to move a rectangle with the keyboard. And you may be wondering, like, where am I going with this? What is the whole point of all of this? Why would I want to move a rectangle with the keyboard? Well, what we just did here is half of Pong. I would like to make Pong for us in Python. Okay? So just like we did in Scratch, come full circle. I'd like to make Pong, and so we need a paddle. I'd like to move the paddle with our keyboard. All right? It's the up arrow and the down arrow. So that's what we need. And there's a way to hook into that with the turtle library and all that together. All right? So again, you can make the turtle your paddle. It's like he can be a square, and then I showed you how to stretch the turtle by like 2 on the X and 2 on the Y, so it kept him a square. But you can stretch him by weird amounts, different amounts on the X and the Y. And that will give you something that looks like a paddle. All right? So apparently this was a good amount. If you stretch the turtle as a square by 1.5 in the X direction and 6 in the Y direction, by default his size is like, what? I think it's 20 by 20. And so if you stretch him by 1.5 in the X direction, that makes him 30 in the width. And then 120 on the height. Like there's his center again. And so what we'd like to do is like make him move up and down. Start him out to the left, somewhere right there, and make him move up and down. All right, so there's a way in the turtle library to use like a keyboard key to do something like when you press a key. There's a way to do it. You say turtle.onKeyPress, turtle.onKeyPress, and then what you do is you pass along the name of the key as the second argument. Oops. And then the first thing that you pass is the name of a function. So it's kind of, hey turtle, whenever this key gets pressed, like the up key, call this function for me. So we're passing along the name of a function so it can call it for me whenever that key gets pressed. That's what we want like right now, right? So that's kind of cool. If you've never seen that before, you can pass a function to a function, because that's what we're doing, all right? So we're going to use onKeyPress to have a function get called whenever we press the up arrow. We'll have like a go up function, and then we'll have like a go down function whenever the down arrow gets pressed, okay? So let's steal a lot of this code. We need like the bounding stuff and all that. But it shouldn't take too much to make like a virtual paddle. We'll call this paddle.py for that reason. And so I don't need draw frame anymore. I don't need any of this. Don't need bounce if hit wall, any of that. I would just like to make my bounding rectangle, bounding square, and I want to make the turtle the paddle. So make his shape square, color can be purple again, and then we want to stretch him by different amounts, 1.5 in the X and 6 in the Y. 1.5 in the X and 6 in the Y. His width is now 30, but we'll forget about that. That's not a problem. And then, let's see. We'll give him some spots in a second, like a random spot to go to. And then get rid of all that. So that's good enough. He's not moving right now. So we drew our rectangle. We put the turtle X, turtle Y in a random spot, and then we're going there with our weird stretched turtle. So there he is. Looks like a paddle, right? So we would like the paddle to be on the left side. So let's give him let's hard code where he starts. Let's be like, all right, the X of the turtle is like not exactly negative 200, like negative 175 or negative 170. I think is good. And let's start him right in the middle as well, vertically, just like Y equals 0. It's like always start there, Mr. Turtle. And so that seems like a good initial spot for the paddle. Yeah. Let's do that. Let's keep it there. And now what I'd like to do is hook into the up arrow and the down arrow keyboard keys. So it's the onKeyPress thing. All right. So I want to say turtle.onKeyPress, give a name of a function, and then also the name of the key, and we'll call that function whenever that key gets pressed. So I'm going to need like two functions. Two functions, one for going up and one for going down. But like once I've got them, I can do it like this. I can say turtle.onKeyPress. I'll have like a go up function, and like I want that to be fired and ran whenever and called whenever the up arrow gets pressed. That's how I'll call this. of a go up function. I want a go up function to be called whenever the up arrow gets pressed, and a go down function to be called whenever the down arrow gets pressed. So now I need to make this function and that function, so it will call them for me. But what I'm doing here is setting up those key press events, we say. Set up functions to run every time the up and down keys are pressed. So that's what we want to do. So we need a go up and go down function. Def go up, something. Def go down, question marks. Let's just work on the go up right now. I think we can deal with go down in a second. I'll delete it. So, all right, go up. What do we want to have happen every time we go up? We want to change the y coordinate of the turtle by some positive amount, right? To move them up, make the y bigger. So, okay, let's do that. So every time we go up, we want to change like the turtle y to be a little bit bigger than it was. Let's be like, I don't know, turtle y equals turtle y plus like 10 or something. I think that would work. And the turtle is the paddle, so maybe we should call this paddle x and paddle y. That would be fun. Paddle x, paddle y. Just renaming the variables. Paddle x, paddle y. So increase the paddle y. And because this is a variable that's a global variable that I want to be able to change inside this function, I got to mark it that way. Global paddle y is going to make it go up. And so you set up the on key press, so it'll like say, hey turtle, whenever the up key gets pressed, call this function. So it'll call this, change the paddle, and then also we need to produce movement, right? This is just changing a variable. You have to actually move the turtle to his new spot with a go to. Bam. And yeah, the last piece of the puzzle is you say, like, once you've set up all your key press events, you tell the turtle, like, all right, now I'm ready for you to listen for every possible key that I've set up. So you say turtle.listen for that. It's like he hears it every time you press a key. Turtle.listen. And that should do it. So here, I've just got go up right now. But if I press the up arrow once, he moved. Look at him. You can hold it in too. And then he also just flies off the screen if you hold it out too much. So we're going to have to fix that too. All right, but that's cool. It's working. Does that make sense? Any questions about this code so far before we fix the fly off the screen? So what's the problem? How does he get up there? Like, we don't want him to go any farther than right here, right? So where is right there relative to his center? So again, his height is 120, his width is 30, like, and this is the y equals 200 line, right? So we don't want him to go any farther, any higher than right here. So like rein him in by half of his height. So 200 minus half of his height, so 60. And so that's going to be what? This is the y equals 140, I think. So don't let the y go bigger than 140. If it does, like, don't do anything. So that's going to be what we need to check for. So, okay. We may have gone too far. Don't let this happen if we try to go past the top. So if we want to make sure we don't go past the top. So if paddle y is like bigger than 140, we want to make sure that like just set it exactly equal to 140. That's as big as it should go. Does that make sense? That's what we'd like. All right. So rein it back in. Never go past the top. So I think that should work. And so now if I press the up arrow a few times, I'm pressing it now, I'm holding it in. He's perfectly bounded, which is exactly what we want. All right, questions about that code? We just want to do the opposite symmetric thing for the go down function. So let's do that. We'll have a go down function now that's very similar to this. What do we want to do when we go down? Go down will get called whenever the down arrow gets pressed, the down key. And you want to make the turtle, the paddle, go lower. So we want to move the coordinate, the y coordinate, and make it smaller. So we're not going to add 10, we're going to subtract 10. And then we also want to make sure we don't go past the bottom. And so symmetrically, it's like make sure that the paddle is not less than negative 140. If it tried to go past that, just like make sure it's exactly equal to that. Just rein it back in. So that's where we'd like to be. Okay. And so we've set up those functions to get called whenever we press those keys. And then we said turtle.listen to start listening for the key presses. And then, all right, I can hold it up. Bam, it gets stopped. And then I can press down, hold in down. And so now I can't exceed the bounds of my screen. A little window. That's pretty neat, all right? And so we have both halves of Pong now. We just got to hook them up. And we'll deal with that in a future programming lecture. I think that's what I wanted to say. Are there any questions about this code? So yeah, I'll give this to you. A great exercise would be to try to make Pong before I do it. You will run into a few roadblocks. Oh yes, you could make another paddle on the other side, and you could hook into like the A and the Z keys or something. Yeah, that would work. Yeah, you could make. Are you talking about having a two-player game? Mm-hmm. Yeah, so you just make a second paddle on the other side, and then you'd hook into two different keys, like A or Z. Yeah, couldn't be up and down at the same time. Yeah, use some other keys on the keyboard for that paddle. Yeah, good question. Let's see here. Yeah, so I think if we're good, that's all that I want to say for the lecture. We'll do Pong soon. It's very exciting. It's like a culmination of a lot of work that we've been working on. The last thing that I want to do today, it's already pitch black, is talk about your final exam, right? So we are in week 15. There are 17 weeks of classes, so we're going to go and have lecture all the way through week 17, okay? And then the week after that is finals week, all right? So week 18 is a special week where there's only final exams in your classes. There's no lectures, all right? So we've been scheduled to have a certain final exam at a certain time by the school, and I'm going to release this final info page for us. So please cross-reference the table on the campus website. I think I checked it correctly, but this is when I think our final will be. So hopefully it'll be right. So the final exam will be in this room starting at 4 on the Monday of finals week. So that's kind of nice. You just get it over with. And so there's no class on Wednesday that week. There's no classes on finals week. Just like come on Monday, take the test, and then we never see each other ever again. Okay. So that's when the final is going to be. And we get an hour and 50 minutes to take a final at this college. So it's a bit longer than our normal class time. We get that chunk of time for the final exam. So it'll be maybe a little bit more questions than we're on the midterm because we get a little bit more time. Okay, so that's when it's going to be. It'll be in this room during this time. We'll just come and take it on Canvas like the midterm. And then here are the topics. Here's what it's going to be about. So I will give you another essay, just like the midterm, and I'll give you a bunch of Python coding questions that are similar to examples that I've done in class, as well as assignments that I've asked you to do in Python. Okay, so yeah, just study those, and then you'll end up doing well on the exam. Okay, like for example, like I'm going to ask you to do something with the turtle. So like make sure that like you've got I/O ready to go on whatever computer you're going to use. You can bring your own laptop if you'd like, but like be ready to write Python programs and test them as you go, because I want to make sure you get as much credit as possible. So you should be running your programs before you click submit, right? So that's what you're going to see, and then I'll give at least half the points to the essay, and then the rest of the points will go to the coding question. So it's kind of half and half, let's say. Okay, so that is what I wanted to say about that. And just like the midterm, it's open book, open notes. Just the only thing you can't use is like AI or something like that, or talk to a human. You can ask me about the questions, of course, but I'm the only person you can talk to during the test. All right, does that kind of make sense? That's when it's going to be, what's going to be on it. I think that is all that I wanted to say. So if we are good, yeah, it'll just appear down here eventually in our week 18 module when we get closer to the test. And on test day, it'll be there for sure, right? But don't forget about it because it's coming up. 1, 2, I guess exactly 1, 2, 3 weeks from now. Or a little less, I guess, because it's a Monday. 3 weeks minus 2 days. All right? So yeah, I think that's all that I have for us today.